a lot of material in this. We're doing an hour tonight and an hour tomorrow night?
Yes.
Right.
Okay. Is there more material, or is this the entire gist of what we'll cover?
There'll be more. What's this at?
That 4 pages is about it.
Yeah, this indicates there's 4 pages down here. I guess. Okay. If I scroll down, I can see all 4 of them. Okay, I got it now. Trying to figure out how to read this PDF file. All right, where would you like to start, Patrick? With 1?
Yes.
Okay. Can you explain the transformations that are, in other words, if the original function is f of x, what is happening to this? There are 1, 2, 3, 4 things taking place. What are they?
Is it a vertical shift down 7?
That's one. Yes?
And then it'd be a horizontal shift to the left 4, because don't you do the opposite of what's in the parentheses?
Good. Which one should you always do first? Reflections. In other words, it doesn't really matter the order that you do these, except if there are reflections involved. And then you always need to do those first. Okay? So I would tend to start from left to right here, and not from right to left. I think you probably went from right to left just because you know what the minus 7 and the plus 4 are doing. What is the minus 1/2 doing?
Isn't that a reflection?
Well, the minus is a reflection over which axis?
Would it be the x?
Correct? And what's the 1/2 doing? They each do different things. In other words, the minus is a reflection and the 1/2 is something else. What's the one?
Sorry about that.
Yeah.
Would it be a shrink?
A vertical shrink. Exactly. So, from left to right, you have a reflection over the x-axis, a vertical shrink by half, a horizontal shift left by 4 units, and a vertical shift down by 7 units. And that's the way I would describe it. In other words, I would start from the left and go right. And the biggest reason for that is that you always want to do your reflections first. And it can result in a different looking graph if you don't do them first. In other words, if you do a vertical or horizontal shift first and then the reflection, you get a different looking graph than if you do the reflection first. So that it's important to remember. It doesn't matter which order you do your reflections, because you can also have a reflection over the y-axis. But as long as you do your reflections before you do your shifts and stretches and shrinks.
Okay.
Okay. So what notation regarding if I had a function f of x, how would I write if I wanted to vertically stretch it by 3 and shift it down by 9?
Would it be fx minus 3?
No. Remember, the vertical stretch is a multiplier in front of the function. In fact, let me list these. I'm going to list all of them. There's 6 things that can be done. And I think this is very important to know what each of these mean. C is just some number. Okay? So tell me what number 1 means. Or the top one.
Wouldn't that be a reflection?
Over
The x.
What's the second one mean?
A reflection over the y.
What's the third one mean?
Wouldn't that be a vertical stretch?
Or shrink, depending on whether c is greater than or less than 1. In other words, it's a stretch if c is greater than 1. It's a shrink if c is between 0 and 1. Okay? What's this one? Yeah, and oddly enough, it goes the other way here. In other words, if c is greater than 1, it's a shrink, a horizontal shrink. And if c is between 0 and 1, it's a stretch. Okay? And an example of that might be if I took the sine curve like that, and I wanted to shrink it, I would have to draw the whole thing in half the width. So this would be, my green would be y equal to sine of 2x instead of sine of x. In other words, the 2 is of this form here, so it's a horizontal shrink if c is greater than 1. And all you have to remember is that they're opposite, and that the vertical stretch is for c greater than 1, and the horizontal stretch is for c less than 1. Really, I mean, if you want to put it that way. What's this one at the bottom?
The second to last or the very bottom?
Second to last?
So that would be a horizontal shift.
Correct. And finally the bottom?
Vertical shift.
All right. Sounds like you know those pretty good. And it's key to understand it in this context, because what they're going to give you is functions like number 1, where you have to figure out how to go backwards. In other words, you have to figure out which of these 6 are taking place. All right, let's go to number 3. Let's go to arithmetic sequences. Have you only had arithmetic, or have they given you geometric also?
I think it's just arithmetic.
Okay. Arithmetic sequences, the common thing is the difference between each number is the same. Okay. So what is that difference in this particular? What's the general format for the explicit nth term of an arithmetic sequence? There's an explicit and there's an recursive. What's the explicit rule?
I used to know that, but I forgot it.
Well, it's the first term plus the common difference times the number of terms minus 1. Now, let's say you weren't sure if that was correct. Let's say this is what you think it was, but you're not positive. Well, let's test it on these 5 terms. Let's figure out what the third term is of this sequence to see if we're correct. In other words, what is a sub 3? We know it should be 21, right? In other words, we can look at it and we can tell that 21 is the third term.
Yeah.
So let's see if our formula is correct. What's the first term?
It'd be -9.
What's the common difference?
315.
Plus 15, because it can be negative. And n is 3, so it'd be 3 minus 1. So now we're talking minus 9 plus 30. That's 21, and that is what we're looking at. So That's correct. That's got to be the right general format. Okay? And that's always where you want to start in math. I can't stress this enough to students, is that you want to start with the general formula and then fill in everything you know. Well, in this case, they're asking what's the explicit for this sequence? Well, specifically, the explicit would be minus 9 plus 15 times n minus 1. And that can be simplified so that a sub n is equal to minus 9 plus 15n minus 15, or minus 24 plus 15n. So if I wanted to know the 100th term, I would just plug in 100 for n. So that a sub 100 would be minus 24 plus 15 times 100. There's your 100th term of that sequence. In other words, if I didn't want to sit there and count it out 100 times, adding 15 each time, I could figure out what it is based on that formula right there. Okay?
Okay.
Now, the recursive. The recursive, excuse me, still trying to learn this program. The recursive means defining your nth term in terms of the n minus 1 term. In other words, the recursive is always going to be that. Well, in this case, it's always the previous term plus the common difference, right? In other words, if I want to know what the 5th term is, I can see that it's 51, but a sub 5 should be equal to a sub 4 plus the common difference, and a sub 4 I can see is 36, common difference is 15, so that gives me 51. So there is the recursive rule. So this is the explicit. Well, I erased what I had for the explicit. Let's see, what did it end up being? A sub n equals minus 24 plus 15n. That's the rule for the explicit. And the recursive would be a sub n equals, well, we don't know what the previous term was, but plus 15. So your two answers are there and there for the explicit and the recursive. In other words, when you give the recursive rule, you can never put down what a sub n minus 1 is because you don't know what a sub n is. We don't know what n is. In other words, each of these depends on a particular n, whether we're talking about the 3rd term or the 50th term. All right. So the next one says a sub 4 equals 11 and a sub 7 equals 17. So how do we figure out what the explicit rule for that sequence is? Start with the general.
You can figure out the difference between the two.
Well, that's one way to do it. What's the difference between the two?
should know this right away.
Well, actually, that's not the best way to do it. Because I guess that actually works. And that maybe is the best way to do it. I'm going to show you two different ways to do this. Okay? The difference between these two numbers is 6, right? So what's the common difference have to be? If I'm going 6 numbers between 4 and 7, what's D have to be?
Would it have to be?
Take the difference between those two numbers and divide it by the difference between those two numbers.
Would be 2?
Yeah. In other words, the sequence must be 11, 13, 15, 17. And the rest of it must be 9, 7, 5, and 3. In other words, this is the first term, second term, third term, fourth term. Whoops, I got it backwards. There's no 3. Let's erase that. So this is first term, second term, third term, fourth term, fifth, sixth, and seventh. And that fits the information they gave us. And I guess you can always do it that way. When you get into geometric sequences, which is probably coming, you can't do it that way because you can have a negative number. But as long as you're dealing in arithmetic sequences, then you can always solve this problem by taking the difference between those two numbers and dividing it by the difference between those two numbers to come up with the common difference. So I still didn't write the rule. I know that this is my sequence, but what is the explicit rule which has to be written in terms of a sub n?
Would it be an equals 5 plus 2, and then that's times n minus 1?
Yeah, and then they usually want you to simplify those. In other words, I can simplify that. What is it?
And 5 plus 2n minus 2.
Which is finally,
It'd be an. Oh, no, that would equal 3 plus 2n.
yeah. And I don't think it matters whether you call it 3 plus 2n or 2n plus 3. Either one is the same. The associative property holds for sure. But your book, if I remember right, they usually put the n first and the number second. So maybe 2n plus 3 would be the way you would want to write it. So you're not going to lose any points if you put it like that. 3 plus 2n. That's just as good. All right. Well, we just covered two huge subjects, translations and arithmetic sequences. So, like I said, there's a lot here to cover, but so far you're pretty good on both of them. So on number 5, list the transformations. First of all, what's the parent function on number 5?
I'm not sure about that.
Well, the parent function is usually everything you're looking at without all of the adjustments. So the parent function must be absolute value of x. Okay? Now, if that's the parent function, what are we doing to it? Start from the left and work right. So what's the first negative sign mean?
Reflecting over the x-axis.
What's the 1/2 mean?
It'd be horizontal shrink.
Think of it like this. If it's outside the function, it's usually vertical. If it's inside the function, it's horizontal.
So it's a vertical shrink.
It's outside the function because we're outside the absolute value signs. So yeah, it's a vertical shrink by a half. And now let's go inside the function. What's the plus 1?
That's a horizontal shift left 1.
Good. And now finally, outside the function again, the plus 4?
Vertical shift up 4.
Correct. So let's graph it. I'm going to graph it in multiple steps here. So let's graph the parent function. That's what that looks like. Okay. And then I'm going to do each one with a different color. So the first one is a reflection of the parent function. So that would be y equals negative absolute value of x. And then the shrink of the parent function, or I'm going to do the shrink of the blue function by 1/2, and that has the effect of making it flatter. You know what I mean by flatter?
Yeah.
Not skinnier. In other words, skinnier would be if those two blue lines were closer together. So a shrink, a vertical shrink, has the effect of making the function flatten out. Okay, and now the shift to 1 unit left, I'm going to do in red. So it's going to look like this. And then finally, the shift, the vertical shift up, I'm going to do in that color. And I'm just going to take my vertex, move it up 4 units. And you'll notice that vertical shifts do not change the shape, nor do horizontal shifts. The only thing that changes the shape are stretches and shrinks. Notice that when I went from the blue to the green, I changed the shape of the curve. That's because it was a shrink. But when I went from the green to the red, I was just doing a horizontal shift, so the red should have the same shape as the green. And then when I went from the red to the brown, I was doing strictly a vertical shift, so it should also have the same shape as the red, and it does. Now, what does domain and range mean? What does domain mean?
Isn't that the x values?
Correct. And what's the range mean?
That's the y values.
Okay. So if I'm talking this function, what values, what's the domain?
Wouldn't it be negative infinity to positive infinity?
Good. What's the range?
Wouldn't it be negative infinity to 4?
Yeah. In other words, you can always read the range by looking at the graph. And that's 4, we know that. And we can tell that this brown line goes down to negative infinity on both sides, but it never gets above 4. So the range is negative infinity to 4. Are you familiar with interval notation?
No.
This is how I would write negative infinity to 4, and it can be 4, so I need a bracket right there. So that's the interval notation for the range. Now, the interval notation for the domain, it was negative infinity to positive infinity, and infinities always have parentheses, never brackets. Okay? The difference between the bracket and the parentheses is whether it can be at that value or not. In other words, if we look at this function, 4 is allowable. So it's a bracket.
All right.
Okay. On to 6. Let me move my thing down here. What's the parent function on number 6?
When the fx or y equals, usually y equals.
That's an absolute value. In other words, whenever you see a v, that usually means it's an absolute value kind of function. Okay? So you can imagine that if I graph the parent function, it looks like this. What's the slope of these lines? What's the slope of that line?
Would it be 1/2?
1 on the parent function.
1 of.
And the slope of the left side is -1. All right?
All right.
So now we have to figure out what is this blue graph that they're showing us? How is it different than what I drew? Well, I can certainly see that there's been a horizontal shift and a vertical shift, right? So let's start there. What's the horizontal shift?
The horizontal shift is right 3.
Which is going to show up how in the function?
-3 would be x minus 3.
X minus 3 inside the function. And the vertical shift is what?
It's up by 2.
And that's outside the function, so I put it there. But there's something else going on with this function. It's like this. So its shape has changed. And the reason I know that is if you look at the slope, that's not a slope of 1, that's a slope of 2. So there's a vertical stretch going on. By how much?
Would it be 1/2?
2. In other words, I need a 2 in front of this absolute value right there. Remember that all vertical stuff is outside the function, all horizontal stuff is inside the function. And it doesn't matter whether you're talking reflections, shifts, or stretches or shrinks. So I know that I've got a vertical stretch. In other words, if you look at my graph, the difference between the blue and the black is the blue is a vertical stretch from the black. It's made it skinnier. If this 2 was a 1/2, then the green would look like this. In other words, if this multiplier in front of the function is less than 1, it makes the graph flatter. If it's greater than 1, it makes it skinnier. And you can use those two terms, or you can kind of think of it as if you were pulling up on the black, it would become the blue. Or if you were pushing down on the black, it would become the green. So what I call skinnier and fatter, or flatter, either one, you get by pushing down or pulling up on the ends of that function. Okay, so this is the answer. In other words, and we could, it's always good when you have problems like this to maybe check a point, because I'm looking at the graph and I can see that a point that should be on this curve is 3, 2, right?
Right.
So does 3 comma 2 fit that equation right there? What would the x be and what would the y be?
On the x be 6? Or no, the x would be 0.
No, if this point is on that curve, then the y has to be 2. So I'm going to plug in, is this an equation? And the x has to be 3. Is that a true statement? Yes, it is. In other words, I picked a point from the graph, I plugged it into my x and y values in my equation, and I still have an equation. I could pick any point. In other words, I could pick 4 comma 4, and then 4 would have to be equal to 2 times 4 minus 3 plus 2, and that's a true statement also. So my equation is correct, but only because, well, I suppose it always comes down to the amount of time you have to take your test, okay, and how certain you are of your answer. In other words, if I was running out of time, I would stop once I got to that. If I had extra time, I would pick a point and plug it in to make sure I was right. You know what I'm saying?
Yeah.
Okay. So how much checking you do, and it doesn't really matter whether you're talking this kind of problem or any kind of problem. Most any kind of math problem, there's a check at the end. If you want to check your answer, you can find out whether you did it correctly or not. But it always comes down to a question of, do you have time? In other words, you don't want to be checking your answers if it means you won't get to answer other questions. So you want to answer everything first, perhaps, and then go back and check some of the ones that you're not 100% sure of by plugging in a point.
All right.
Okay. Number 7. Piecewise.
I have one question.
Okay.
Will the absolute value of x always have a slope of 1?
Well, it actually has a slope of 1 only to the right of the vertex. In other words, if I draw it, notice that the slope to the left of the vertex is minus 1. Yes. In other words, it will always have a slope of either plus 1 or minus 1. What it really is a piecewise function. Here's what it is. It's y equals x when x is greater than or equal to 0, and it's y equal minus x when x is less than or equal to 0. And instead of writing it as a piecewise function like this, they combine it and write it as y equal the absolute value of x. Okay? So let's talk about piecewise functions. The most important place to start is with the domain. Okay? Now, personally, I really kind of like to go left to right when I'm talking domain. Doesn't everybody? And yet, for some reason, they decided to go right to left on this. In other words, I normally tell everybody to start in the upper right-hand corner when you're looking at a piecewise function. And what that does is it tells you, if I start in the upper right-hand corner at the number 2, and just in my mind, I'm going to draw a dotted line here, and I'm going to graph that function, 1/2 x minus 2, everywhere in that range. And then when I go to the left of minus 1, I'm going to graph this. Well, minus 1 is over here. This is an odd piecewise function. Usually piecewise functions cover the entire domain. Well, this leaves a gap between minus 1 and 2. But I'm plotting this function over here in that area. Okay? And that's the way you want to think about it. So let me erase that and erase that. Now, normally your domain starts from negative infinity and goes to positive infinity. For some reason, in this problem, they're going from right to left. Notice that the first domain they refer to is this one, to the right of 2, and the next domain they refer to is to the left of negative 1. Well, that's okay. I mean, I can deal with that. I don't need to go left to right. It's just that most people tend to think left to right, so they like to work left to right. If I was telling you this piecewise function, I would have put the bottom row first at the top, and then I would have put this row below it. And that would have allowed me to go from left to right. Doesn't matter. We'll go right to left. Now, to graph this function to the right of 2, I know it's a straight line, right? It's a linear function. I mean, it's not x squared. It's not absolute value of x until we get down to here. That's linear. That's a straight line. So the way to graph that is to find a point, apply the slope, and graph the line. Well, it doesn't go to the y-axis, so I can't really graph the y-intercept. I know the y-intercept is minus 2, but I'm over here. In other words, I've got to graph it over here. I don't cross the y-axis. So how do I figure out the first point? Plug in this number for x. What do you get? Well, you get 1/2 times 2, which is 1, minus 2, so minus 1. So in other words, when x is 2, y is minus 1, which is, we'll call that right there, minus 1. In other words, that point is on that curve, and it's a closed dot because it's greater than or equal to 2. And now how do I find another point on that line? In other words, in order to draw the line, I need a second point. Apply the slope. What's the slope?
Isn't it 1 over 2?
How do I get that?
You go up 1 and over 2?
I go up 1 and I go to the right 2. Okay, so that's about there. And now I can connect those two dots and put an arrow on it because it goes to infinity on the domain. And I have plotted the top part of that. Now let's look at the bottom part. Well, the bottom part, I don't have any graph at all between minus 1 and 2. The domain doesn't cover that. In other words, the domain goes from negative infinity to minus 1, and then it goes from 2 to positive infinity. So the next point that I have to plot is on this dotted line that I've drawn here. And when I draw a dotted line like that, it means that it's not in the graph. I'm going to erase it. I'm only drawing that dotted line to give you the concept of you're paying attention to the domains. Okay? But what you want to do here is, even though it says x is less than minus 1, to get that first point, I'm going to plug in minus 1 into this function here. So what do I get? When I plug in minus 1, what's the f of x value? In that second function, plug in minus 1 for x and tell me what f of x is.
F of x when
In other words, it's minus, I'm plugging in minus 1 for x, plus 3, plus 5. Now, what is that equal to?
Would it be 2x plus 5?
No, I don't have an x anymore. In other words, I'm looking for a point, and I've plugged in minus 1 for x. So what's the answer to what I've written right there?
Would it be 2 comma 5?
Well, it's the negative minus 1 plus 3 is 2. So 2 is inside the absolute value, plus 5, which becomes minus 2 plus 5, which is equal to 3. Okay? So the first point that I want to start with is minus 1 comma 3. In other words, when x is minus 1, f of x is 3. And it's an open circle, not a closed circle, because in this case it only applies when x is less than minus 1, not less than or equal. If it were less than or equal, I would make that a closed circle. Since it's less than only, I made it an open circle. Now, we have to find how to graph the rest of it. We know that's where it starts. And we know that we're looking at the absolute value function. So, and it's been reflected over the x-axis. So instead of looking like this, it must look like that, right?
Right.
And it's shifted 3 units to the left and up 5. Well, I really only need one more point. Hold on a moment. What if I plug in minus 3 for x? What's f of x equal to?
Would it be 0 plus 5?
Okay, so it's up here somewhere. So I'm pretty sure, well, no, I don't know that for sure yet. How do we find the vertex of this thing? What if I plug in minus 4 for x? What am I looking at?
You're looking at negative 1 plus 5. Which is
4. So it turns. So that point is on the curve, right? So it appears what I have is this. And that looks like an inverted absolute value function that's been shifted 3 units to the left and moved up 5 units. And so I know that curve is correct. That's 5 right there. This is a little tough. I'm not sure I've had to do a piecewise function where one side was a linear and the other was absolute value. But this is not a bad way to do it. Find your starting point and then find your vertex by making whatever's in the absolute value equal to 0. That's the way to do it. That was my vertex. was minus 3. In other words, the vertex is minus 3 comma 5. And so my entire function ends up looking like this. That's the way it should look on that graph there.
Okay.
And notice the slope on my absolute value part, that's a -1, that's a +1. And that's because there's the coefficient of x is 1. It's not 2 or 1/2, it's 1. All right. Piecewise functions, they always want you to be able to go both ways. In other words, you have to be able to graph it given the piecewise function, and you have to be able to come up with the piecewise function given the graph, which is what we have in number 8. If I can get it. There we go. Now, remember when I said that I always prefer to go left to right?
Right.
Well, what that means is my f of x is going to be equal, and I'm going to start in the upper right. So if I'm going left to right, what should that thing say? In other words, the function goes here, the domain goes there, and then I can tell that I got two functions. There's another function there and a different domain. So if I'm going left to right, what should this upper right x say?
And then the
X is less than or equal to what number?
-4.
Correct. Less than or equal to -4. And what is the function? What goes in place of the circle? This horizontal line there. How do you define that as a function?
Not just -4.
No, horizontal lines are always y equals some number. Vertical lines are x equals some number. So in this case, it would be equal to 6. You see that? You see that that horizontal line is defined by y equals 6, or
Yeah.
f of x equals 6. And you know by now that f of x and y mean the same thing.
Yeah.
Okay. And it's less than or equal to -4 because there's a closed dot right there at x equals -4. So what's the equation of the line, the right part? But before we figure out the equation of it, let's figure out what the domain is. What should the domain say on the bottom right?
It's going to be x is greater than 2 or -2.
-2. And I think that's the best way to deal with these piecewise functions, is to specify your domain first and then figure out the function. Okay? Well, that function that we're looking at is a straight line. Straight lines can be written in the form y equals mx plus b, especially if they go through the y-axis. What's b? In this case?
It would be 6.
And what's m?
It would be 1/2.
How many up do I have to go?
It would be 2/1.
Yeah. So the slope is 2. So that is the equation of that line we're looking at. Only I don't need the y because I've already written f of x, so that would be 2x plus 6. And now I have In other words, I've drawn the graph and I've given the piecewise function. And you could go either way. If I gave you this, I would expect you to be able to draw this graph, or given the graph, I would expect you to be able to come up with the piecewise function. Okay? All right. For tonight, we have about another 8 minutes. You want to just keep going in order, and then I guess tomorrow night we're going to pick up wherever we leave off tonight?
Yeah.
Okay. So let's go to 9. Yeah, there is a lot of material in here. Which is, I got a lot of Algebra 2 students this year. And I didn't realize this before this year, but the first 4 or 5 subjects they hit you with in Algebra 2 are all tough. Piecewise functions, solving 3 equations and 3 unknowns, word problems. In other words, none of this is particularly easy. So let's graph the number 9. Shall we? Yeah, we're going to do that next. How do I got 2 inequalities here. So how do I go about graphing them? First of all, graph them as if they were equations to start with. Okay, even though they're not equations, I'm going to make that an equation because I know how to graph that line. How do I graph that line?
Put in the mx plus b form.
What's that?
Put in the y equals mx plus b form.
Correct. Put it into y equal mx plus b format, which means I'm going to move the x over, making it minus. So now I can graph that line, right? Where do I begin graphing this?
At -3.
And what next? What's the slope?
It'll be 1 over 1.
-1. See, there's a negative sign in front of that x. So m is -1, which means I got to do what? In other words, if this point is on the graph and I need a negative slope, I got to go up 1 and which way? Left or right?
Left.
Correct. So there's my second point. Okay. Now, do I need a dotted line connecting those 2 points or a solid line?
Wouldn't it be a solid?
Yeah. So I'm going to do that. That's the equation of that. Now, it's not an equation, it's an inequality. So I have to figure out which side I'm going to shade. Well, which side is it?
Wouldn't it be the left side?
It's because we're always defining it in terms of y, it's never left or right, it's always up or down. And remember, this thing is y is greater than or equal to minus x minus 3. So the way you determine which side to shade is you always go to the y-axis. I'm not looking left or right. I'm wanting to know whether I go up or down. Should I shade above or below the line?
Shade below?
Greater than.
Above.
Above. So I'm shading everything like that. Okay? Now we got to do the same thing with the second one. I'm going to erase some of this stuff just so that I have room to do the second one. I'm going to do the second one up here. So first of all, we write it as an equation in order to figure out how to graph it. Excuse me. So I'll put that in y equal mx plus b format so that I get a y.
Did you get 4y?
You do. You get 4y equals 6x plus 16. And then you get y equals 6/4 x plus 4, which is y equal 3/2 x plus 4. And it's not an equation. It's y is less than this. So first of all, let's graph the line from this. Where do I start?
4.
What next?
When you go up 3/2.
Always tell me when you say over, that's not specific enough. I need left or right.
To the right.
Okay, so I'm going to go, or I could go down 3 and left 2. Notice, same thing. And I'm going to do that because that fits on my screen. Okay, notice that I still have a positive slope. It doesn't require me to go up and right. I can go down and left and still get that positive slope. Okay, and should that be a solid line or a dotted line?
That would be a dotted line.
Correct. That is a dotted line because it's less than only, so it's like that. And which side of the dotted line should I shade?
Wouldn't it be the
Don't say right or left, say up or down.
It'd be down.
Below that y-axis. In other words, this area here, if you can see it. So in the first case, I shaded everything above the solid line. In the second case, I'm shading everything below the dotted line. So what I'm left with is the area that is both shades. In other words, one way to do this is you can use horizontal stripes for one, and vertical stripes for another. Okay? Well, I'm going below the dotted line, so I'm going to use vertical stripes everywhere below the dotted line, and then wherever I have both stripes, that's the area in common. And that area is that area there. And that's how you do these.
Yeah.
Okay? And that's probably a good place to stop. And we'll start with number 10 tomorrow.
All right.
All right, Dave, we'll pick you up tomorrow.
All right, David. Good talking to you guys again. Talk to you tomorrow.
Good night.
Bye-bye.